In this video, we'll see about what is superposition theorem. So what is a superposition theorem in a linear circuit? First, the main point you need to remember is superposition theorem works only on linear circuits. It is applicable only on linear circuits, and it will not be applied on non-linear circuits. This is the main point you need to follow. And in a linear circuit, the voltage or current across a resistor, here a resistor is an element in this case, is the total of the voltages or currents caused by each independent source separately. For example, if we are having 6 volts of voltage and 2 amperes of current for resistance 4 ohms. So how will calculate is by eradicating for the first time 6 volts, and you'll calculate this part, and then again you'll have 6 volts and remove 2 amperes and calculate this part, and you'll add the answer. This might be very a bit confused for you now. To understand this properly, we'll deal with an example. Here each independent source means it might be a voltage or current, which is V by A. V is the symbol of voltage and A is the symbol of current. Now, how to apply superposition theorem? If we are dealing with voltage source, I mean if we are removing some voltage source, at first this will be our voltage source. And if we are trying to eradicate this one, we will get a short circuit. Short circuit means it will be in this form. In this case, we'll have 0 voltage if we are applying for short circuit. And if it is for current case, so this is your current. And if you are trying to eradicate this current source, then we'll use open circuit. So this will be your open circuit. And here we'll have 0 amperes. At a time, we should not turn off dependent sources. We shouldn't touch them also. So keep this point in mind. Do not turn off dependent sources. We should only focus on independent sources. We should not focus on dependent forces. So let us deal with an example now. So now this is the example given for us. Use superposition theorem to find out the voltage across 4 ohm resistor. This is our 4 ohm resistor, and we need to find the voltage across 4 ohm resistor. First, to apply the superposition theorem, we need to identify the independent sources here. So first step is identify independent sources. So here your independent sources is 2 amperes of current and your 4 voltage. So we are having 4 volts and 2 amperes of current as our independent sources. Now, since we are having 2 independent sources, we'll use 2 cases in this problem. Suppose if we are having here another voltage or another current, we'll use 3 cases. How many independent sources are there? Those many cases we'll be using. So for this particular problem, we'll use only 2 cases. So the first case, what I'll do, I'll remove this 2 amperes of current and I'll solve the voltage. So let us see what will happen if I am removing this 2 amperes of current. Since we are removing current, it will be an open circuit. So let us see the diagram. So we are here eradicating 2 amperes of current. So our diagram will be in this form now, circuit diagram. So here we'll be having our this is our 4 volts. Since we are dealing with current, this is our open circuit. And this is our 4 ohm and plus and minus. Okay, so we are having this particular diagram, updated diagram now. Now what we need to do? We need to assume that current passing, since this is an open circuit, the current here will be 0. There will be no current in this generated in this particular loop. So we need to consider only this loop. So the current passing in this loop, let it be I1. Okay, and the voltage for this loop that we need to find out be V1. So the voltage here we are going to find out is V1. So what we'll do now, we are assume current passing as I1, and now we'll apply KVL here. So in superposition theorem we apply KVL. So after applying KVL, what we'll get? We need to find out the equation. See, in KVL we are having here we are having 6 ohms resistor, 4 ohms resistor and 4 volts. So since the current flows from higher potential to lower potential, so first we have taken our 4 volts, and now since the current is flowing from this particular point to here and then again here, so it's a potential drop in this case. So we'll get 4 volts minus 6 into I1. What is the current here? I1, and then again minus 4 into I1. Why we are taking here negative sign is, it's because of the potential drop. Okay, since it is a potential drop, we are taking negative sign. And now why we are having this I1 is, as per the Ohm's law, we know that V is equal to IR. Since we need to find voltage, our I is I1 and our R is 6 and 4 respectively. So this will be equal to 0. Now let's see what will happen. Now since we found out 4 volts minus 6I1 minus 4I1 is equal to 0, we'll solve that equation now. So we are having 4 minus 6I1 minus 4I1 is equal to 0. So now 4 minus 10I1 is equal to 0. 4 is equal to 10I1, and your I1 will be 4 by 10, which is 2 by 5 amperes. So you are getting I1 is equal to 2 by 5 amperes in this case. So now what we'll do? I1 ఒక్కటి కనుక్కుంటే సరిపోదు. We also need to calculate voltage. So our voltage is V is equal to IR. In the question they are asking to find the voltage at 4 ohms resistance. So V is equal to 2 by 5 into 4, which is 8 by 5 volts. So our V1 will be 8 by 5 volts in this particular case. So in case 1, what we are doing is, we are eradicating the current, and with the help of voltage source we are finding the value. Now in the case 2, what we'll do? We'll eradicate the voltage source and we'll use current source in this case. So now in the second case we are eradicating voltage source. After eradicating voltage source, this is the updated circuit we are having. So now what we'll do? We'll apply current division rule in this case. If it is a voltage case, then we'll apply KVL. If it is a current case, then we are applying current division rule. How you'll apply this rule? See, what is the current entering into this circuit? Before knowing that, let the voltage for this be V2 and the current be I2. Now we need to find out the current. So your I2 will be, the current entering is 2 amperes, and how it is flowing? It is flowing through this particular resistor and then again into this loop. So first you will have 6 ohms by 6 plus 4. Total resistance you are calculating. So 2 into 6 by 10. So you will get 6 by 5 amperes of current. So your I2 will be 6 by 5 amperes. Now you need to find out voltage. So your V2 will be I2 into R. At 4 ohms resistor they are asking us to find the voltage. So your V2 will be 6 by 5 into 4, which is 24 by 5. So after finding V1 and V2, we need to find V equivalent resistance at 4 ohms. Since in the question they are asking us to find at 4 ohms, we will get V1 plus V2. So now what is our V1 value? It is 8 by 5 plus V2 is 24 by 5. Since then you will get 32 by 5 as your voltage. So your V equivalent at 4 ohms will be 32 by 5. So this is how you solve problems using superposition principle or theorem. If you are having any doubt, let me know in the comment section.